Alrighty, so this is the last thing that we're going to do kind of together before you do work on something yourself. So what we are looking at is, I'm going to put this down a little bit, get a little bit more straighter, is we're just going to classify the numbers as rational or irrational. So remember on those notes that we just took, rational numbers terminate or repeat as decimals, can be written as a fraction, whole numbers, and perfect squares, whereas irrational are non-perfect squares. They are also non-terminating and non-repeating. All right, so we're not going to do all of these probably, but we'll go through a few. So I'm going to look at the first one, negative 321. Well, doesn't have any decimal that I see, which means it's terminating. So negative 321 would go into rational. The square root of 16, we looked at this before. We're going to use our calculator or use our brain, and the square root of 16 equals 4. Awesome job. So again, that's a perfect square. We talked about pi. It is a number that never repeats and never terminates. So pi will go here. All right, I'm going to kind of skip around some. 0, where would 0 go? In our rational numbers. Good. All right, let's look at this. This is negative 0 and 89, 89, 89. So do you see how it's a pattern, right? How it has that repeating pattern? These two numbers repeat. You could write this as negative 0.89. And remember, you would just put a line over that to show that it's repeating. So when I put it up here, that's how I'm going to write it. Okay, so that is in fact rational. Whereas if I look at this one right here, that dot, 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 that's called an ellipse, is at the end. And do you see how there's no pattern of repeating? So that's why this would go here, and I would have to write the whole entire thing. All right. One thing that I don't see on here that sometimes they'll give you is something like this. They'll put 0.101101110. So you might look at that and say, well, Miss Davy, it's not the same numbers repeating, but like it has a pattern to it. But because it is not specifically this number is repeating or this pattern of numbers is repeating, it only has a pattern to it, it's going to go in irrational. So this one would go here, okay? Whereas if you saw something like this, 0.79 with a line over it, right? This is a repeating number. Even though the whole thing doesn't repeat, right here repeats, and it's telling you that. So that is rational. So those are probably the two hardest things that you don't always see, but are very, very important. Okay? Something else that you will see is something like this. So the square root of 16, we've already talked about that. That's 4. What's the square root of 4? 2. So because this is a plain old fraction and these were perfect squares, this actually would go in our rational numbers. And I didn't do that right, okay? Whereas, do you see right here? Well, 7's perfectly fine. It's a fraction. But is the square root of 40 just a plain old number, or is it a decimal that doesn't terminate, non-terminating, and is non-repeating? It is. So this one would go up here. Okay? And now I'm going to have you do a couple, and you're going to put them in the spot where you think. All right? So this one, and this one. Pause your video, and then you are going to come back. Welcome back. You should have gotten rational, irrational, and irrational. All right? Great job, guys.